All right, recording has just started. Welcome everyone to the second Interop discussion. Today's session is going to be focused on interoperability use cases for ETH and USDC. Within USDC, we'll be talking about the bridged USDC standard, as well as how to go between chains that have native USDC and bridged USDC. Just as a quick reminder, interop is the ability to send messages between chains in a dependency set, and there is a superchain token standard by which we're able to turn that message into asset transfer between chains. If you haven't joined previous sessions, there is the Interop FAQ, message passing specification, and a YouTube video from Mark Tyneway from OP Labs that gives a good overview for additional context. Without going into too much detail, when you think about the anatomy of a cross-chain message, so let's say as Zain, I want to send one OP from OP mainnet to base, there's actually two transactions that happen. The initiating one on OP mainnet and then the finalizing one. In addition, obviously there's a set of interoperating chains, and then within each chain that is interoperating, they're going to need to run not just the sequencing node, but a verifying node for each chain in the dependency set. Just something to keep in mind as we progress. So today's session, what we want to be focused on is getting feedback on ETH, the bridged USDC standard, as well as how we're imagining portability between chains with bridged USDC and chains with native USDC. Today's session is not going to be focused on ERC20s, nor native tokens like the OP token. We'll host a second session to follow up on that. Okay, so interoperable ETH, tentative, this is to go live at the end of Q4 of this year. What this means is you'll be able to take ETH from source chain to destination chain within one block. Now, the one nuance with ETH compared to other tokens like native tokens or standard ERC20s is there is the complication of wrapped ETH. So hypothetically, if I'm moving one ETH from source chain to destination chain, if there's not sufficient liquidity on the destination chain, I might not be able to unwrap that. To address that limitation, we are introducing new pre-deploys that would allow for minting and burning of Ether between chains. I'll pass it over to Mark in a second, but just to go through the flow of what that would look like. So let's say a user, we have chain A and chain B, which are interoperating, and L1 Ethereum. The user wants to move 5 ETH from L1 to chain A. So what ends up happening is in your chain A's lockbox on L1, you have 5 ETH locked there. On chain B, you have 0 ETH because the user didn't interact there. And then on chain A, the user has the 5 ETH and 0 ETH on chain B. Now, the second action the user wants to take is, I want to move 4 ETH from chain A to chain B. Now, notice on step 2 here, the values in the L1 lockbox don't change, right? What changes is 4 ETH is moved to chain B, so the remaining value of ETH on chain A is 1, and 4 ETH on chain B. Now, if the user wants to move off of chain B back to L1, notice that there has to be sufficient liquidity in the L1 lockbox of the chain that the user is on. Mark, do you mind talking a little bit about this?
Yeah, totally. So basically, right now, an OP Stack chain has its own set of bridge contracts on L1. And the problem is that each L2 network is kind of like its own island, right? So the solution that we're going for in the short term is simply allowing the liquidity to flow in between the L2s without modifying the L1 bridge contracts. So what does this mean? This means that, let's say that there's chain A and chain B, and people deposit into both chain A and chain B. Then let's say everyone, sends a cross-chain transaction for all of the ETH from chain A to chain B. Now we kind of have like chain B holds all the ETH, chain A has no ETH, but on L1, they're different bridges. So if you want to like withdraw, you need to like rebalance between the L2s to be able to withdraw. Now, in the long term, we would like to, pursue a, shared bridge sort of design from L1, but we don't think that that is super necessary for the first release. Because really like the main pain point that we're trying to solve is like make it feel like one chain from the perspective of L2. And if we look at the people that are actually doing withdrawals, they're more kind of smarter actors that actually manage rebalancing. And we think that this rebalancing won't be like that big of an issue, especially if the cross-chain transactions are fast enough between the L2s where you can very easily rebalance and do a withdrawal. But if you don't think so, would love to get some feedback from you.
So very specifically, as you look at this concern, I know we've talked to the Gelato team. I think some of them are here. They mentioned potential griefing vectors, where if someone hypothetically had, I think there's around 2 billion in ETH on OP mainnet, they could move that directly over to Base, withdraw from Base, and then those users on Base would have to move over to OP mainnet to exit via there, hypothetically. Any other concerns that y'all foresee with this design?
I can give one thing that we've run into at some points. If you build automated, if like a team builds smart contracts that just assume that this liquidity is going to be available and does withdrawals automatically, that could cause problems. So specifically, like for Across, this is how our contracts work today, is there's like a permissionless process by which someone can initiate the movement of funds back to L1 if the protocol deems that necessary. And so in this case, like you would just have to revert, and the sort of you'd have to have a cross build in sort of more complicated operations to like figure out where the liquidity is and move funds around. So smart contract systems might have issues with this approach.
Yeah, Zain, I think you're going to get into some of this stuff later in some of your slides too. And like, okay, I'll be honest, like, so I'm on the Across team for everybody else listening, and we like the intent idea, and just particularly the standards. We're not trying to make this be a vendor lock, and we're trying to make this be a very neutral, like credibly neutral standard for how you could do cross-chain intents. And I'm very excited about all these examples because I think it can make intent systems cheaper and better. But I do intuitively like the idea of a solver or more sophisticated actor being the ones that have the logic to understand when a given route doesn't have liquidity and know how to like route, like literally is what I think a solver is supposed to do, like route the unwind in the most intelligent way possible. So yeah.
Yeah, definitely. And my apologies, I should have mentioned this in the beginning, but on this call, you have teams both contributing to the super chain, like OP Labs, Wonderland, Base, Lisk, etc., as well as we're joined with members from Circle, Across, and Gelato as well. So just closing the loop on what Matt, Hart, and Mark alluded to, right? I think the design choice we're taking here is how do we enable asset interoperability quickly and safely while pushing some of that complexity off into like a later iteration of interoperability. And potentially what we're saying here is that more sophisticated actors, whether they're solvers for relayer networks or centralized exchanges, et cetera, will be able, with sufficient documentation, to manage some of these constraints in this design.
Yeah, Zain, what I will add to Mark's point is like we see it in our data already. Like withdrawals back to L1 are becoming rarer and rarer. Meanwhile, L2 to L2 transfers are becoming more and more common, and also like lower sizes. So it's actually pretty cool. Post Dencun, we've seen like the average L2 to L2 bridge transfer go from like $500 down to like $50 now.
Yep.
And those are exploding while the withdrawals back to mainnet are going down. So like directionally, over the long run, even in this design, I don't think it's an issue, or rather, it will become less and less of an issue too.
Yep, and if anyone wants to see some of that data, I think in the last slide in this deck, there's like an example of some L2 to L2 transfers and like the notional size for there to corroborate Hart's point. Okay, so if there's no other feedback, we linked the design doc for Interoperable ETH here. If you have any feedback on it as you're daydreaming about the superchain, please join the GitHub discussion. We want to build this together, so your feedback would be invaluable. Okay, USDC. I'm going to set a ton of context up front here, and then we'll get into it. So with USDC, there's two things that are coming here. One is the bridge USDC standard. So Circle, in order to reduce the fragmentation between previously called bridge USDC and native USDC, if the chain ends up getting native USDC, they launched the bridge USDC standard. The bridge USDC standard enables a chain operator with agreement with Circle to automatically upgrade that bridge USDC into native USDC to prevent the liquidity fragmentation that we observe on some chains like OP mainnet. Now, today, we hear you loud and clear. There's no reference implementation for how the bridge USDC standard that Circle authored works with the OP Stack bridge. So Wonderland, which is a core contributor of the Optimism Collective, they are working on a version of the bridge USDC standard that's in development right now, audit plan for July 15th, excuse me, and go live circa August 24th that would enable any chain operator to deploy a compliant version of the bridge USDC standard that also works with the OP Stack bridge. So if you're a chain operator on this call that does not have USDC on your chain yet, this is likely a route that you can go that would allow you to automatically upgrade into native USDC when the time comes. Okay, so now that you have bridged USDC on your chain, actually, before we talk about Interop for bridged USDC standard, Skeletor, I do want to pass it to you, who is a core contributor at Wonderland, to talk through some of the flows that we have for the bridged USDC standard.
Awesome. Thank you, Zain. Okay, so it's pretty straightforward. The main thing we'll have, or you as a chain operator will do, is just with a single transaction call an L1 Ethereum mainnet factory contract, point to your specific cross-domain messenger or /portal contract underneath. And then this will deploy, as I said, with a single transaction, all the necessary contracts on your L2. This is mainly for two reasons. One is to ensure the same address on multiple or different chains, but also to ensure the implementation code, since those contracts are upgradable contracts as per the bridge USDC standard. Also to basically make users' life easier when trusting a specific bridge USDC implementation on a specific chain that it's, let's say, controlled by a third party. So basically on L1, we will just have the adapter that serves, maybe we can go to the next slide. There you go, yeah. So for deposit, we'll have super straightforward, the adapter, which acts as the entry-exit point, as well as the lockbox for L1 USDC, native USDC, let's call it. And then you will have on L2 the same adapter, but it doesn't act obviously as a lockbox, since it has mint and burn capabilities on the bridge USDC that was deployed on the previous step. So basically the user will approve this bridge adapter. It will basically transfer the funds into it. Basically those USDC on L1 are backing the entire supply of the bridge USDC on the L2, and this is super important, and this is part of the spec that Circle wants to, basically have as a trust assumption in case, for the specific flow of upgrading into native. But we'll go to that later. Basically, the only thing that we're doing is on deployment, we are setting all of these L1 and L2 specific addresses for the adapters on each other, both on the L1 and on the L2, and we just have a specific modifier that trusts the OP cross-domain messenger and checks if the source address is the adapter on the other end. We can go to the next one. Yeah, so here, so upgrading into native USDC. For you guys that are not familiar with it, the current flow is that Circle, obviously, after some talks with the Circle team, Circle will provide a specific address that both the adapter in this case and the specific implementation of Bridge USDC on the L2 will need to point to. This address is a specific smart contract that has just one function that is going to be calling, let's say, the transfer ownership methods on both the adapter and the Bridge USDC. So we have a specific upgrade flow here, which is pretty straightforward. And this is obviously, since you will only upgrade to native USDC once, this is only going to be used once. So you will signal this specific Circle own contract address on L1, and this will take care of everything for you. So you only have to basically do a single transaction, super easy. And then obviously Circle takes it's basically up to Circle to take the responsibility of the rest of the upgrade, which in turn includes burning the locked USDC on L1, since now all the USDC on L2 are actually native USDC and not anymore backed USDC on L1. So yeah,
Cool.
Yeah, go ahead, Zain.
Thanks, Skeletor. And actually, before we go into this, any questions around the Bridge USDC standard? And Hart, I see your question. We'll get to that in a second. Okay. Mauricio, I think you might be on the call. I don't know if you have an opinion on Hart's question here, but Hart, from the conversations I've had with chain operators, it's generally the desire to get native USDC on their chain. And what that means is, as a precursor to that, the Bridge USDC standard enables them to, assuming that a deal is met between the chain operator and Circle, for them to get native USDC eventually.
Scary, I don't know if you want to reply to that. Otherwise, I can take the two questions in the chat.
Oh yeah, go ahead.
Yeah, so Hart's question, is there a reason why a chain would not want to? Not that we are aware of. If anything, we see a lot of chains wanting to adopt it, and they reach out to us to help it deploy it. So we're working with the OP team and the Wonderland team to try to make it as easy as possible for anybody to get it. And so we're trying to lean in that direction. And Rishi, no, if anything, this is the same USDC standard, which is trying to make it easier and easier to deploy. So every team doesn't have to do a custom implementation to get it.
Thanks, guys. That makes sense. I just wanted to see if I was missing anything. Makes total sense.
Amazing. Cool. So let's say you're a chain operator. You now have Bridge USDC that is compliant with the Bridge USDC standard, and you want to interoperate or move assets from your chain to a chain that has native USDC. One thing to note is that tokens with different security methods can't be fungible. So token with Bridge USDC has a slightly different security method than a chain or than native USDC. So that means we cannot use the Interop protocol to move those tokens between each other. So I think Hart alluded to this a little bit. So that is why we're proposing using an intent-based system to enable portability of Bridge USDC and native USDC. So let's take an example here. Let's say a user is on chain A that has native USDC, and they want to buy an NFT on chain B that has Bridge USDC. So what would happen here is the user would express that intent. Hey, I want to move 5 USDC. The user probably doesn't know it's native from chain A to chain B. At that point in time, there's a marketplace of solvers or relayers competing to settle that user's intent, right? So in this case, the solver says, hey, I'll help you do this for 2 cents, right? Or 0.02 USDC, excuse me, right? At that point in time, the user will send the 5.02 native USDC to the settlement contract just via a simple ERC20 transfer. And almost at the same time on the destination chain, in this case, chain B, the solver who is escrowing some bridged USDC funds releases that to the user on chain B. So from the user standpoint, they're able to get bridged USDC or the 5 USDC within 2 seconds. Now, let's say you play this scenario over 100 times, 1,000 times, 1,000,000 times. Well, the solver on chain A is going to have excess liquidity than they have on chain B. So how do they rebalance this, given that these are 2 different token standards? Well, hypothetically, what they could do is take the excess funds on chain A that has native USDC, use CCTP to move from chain A to L1 Ethereum, and then just do a normal deposit transaction into chain B to rebalance on that side. Now, what we're doing here is we're mitigating that complexity of using 2 different messaging protocols in this case, and pushing that off to the specialist or the solver, the market maker, the centralized exchange in this case, and still unblocking the user for getting the asset that they wanted and enabling a good user experience. I'll pause there. Any questions that are coming up here related to moving between chains that have native USDC and chains that have bridged USDC? In case.
Just maybe one extra clarifying point. When you're trying to go from a native USDC to another native USDC, like say from base to OP native, you can still go through CCTP. So this is only when you're trying to go from native to bridged or bridged to native.
Thanks.
I could probably anticipate some questions here, Zain, of where people might, if that's helpful. I also don't want to.
Yeah, please. Hart, I think there's two questions here in the chat. I can take the first one from Harry if you want to take Roberto's.
Yeah, sure.
Cool. So Harry, I think for some of the work that we're doing with like the superchain bridge interfaces, we are working with Across on enabling ETH and USDC transfers among the superchain. There is an EIP out called EIP 7683, which aims to make it one can build an intent-based system off of this marketplace of solvers. Hart, I don't know if you want to speak a little bit about that as well.
Sure. I'll put the link in the chat. This is something that we developed with Uniswap as an open standard. Oh, Ryan already beat me. We developed with Uniswap as an open standard, and we want feedback on generally. And I can't be explicit enough. This is it's not an Across standard. There's no vendor lock-in. It's not a Uniswap standard. It's just a very simple mechanism for doing a cross-chain intent. To Roberto's question, you can imagine a system here, particularly with OP native interop, that introduces no additional trust assumptions in like who has the user funds. So for example, if we follow the diagram right here, the user deposits into a settlement contract that effectively escrows their funds. The solver then fills the user with their own money on the destination chain, that's chain B here. And then the user funds are only released from the settlement contract when OP native interop confirms that the fill did in fact happen. So you could use OP native interop to go from chain B back to chain A using the same security, the same security assumptions of both of the native interop function. And you can do that in batches too, which might save some money. Zain, one question I had for you, in the way Optimism is thinking about this, native USDC would not be like bridgeable via OP native interop, right? It would only be bridgeable via CCTP. Okay.
Correct.
Yeah. And likewise, the bridged USDC that is like, it is a kind of like bridged USDC, would the OP native like ERC20 standard, would it fit within that? Like, would bridged USDC be bridgeable between other chains that have bridged USDC, or unclear right now?
Cool. That question we actually have a slide for, because that one we need a little bit more discussion on from chain operators on our design.
Okay.
So I'll table that question, and then we'll go through an example of interop for bridged USDC in a moment.
Okay, cool. So I think the only downsides to this, just to make sure, because like, again, we want to approach this in the most intellectually honest way possible. So we want everybody to understand the trade-offs with the intent space. So the downsides here, the solver here has to have some inventory. In this case, they have to have some inventory of bridged USDC on chain B in order to fill the user, right? So there is some cost to that solver maintaining inventory to fill this request. It's not very, there's also then going to be, if they end up having too much inventory on chain B, like, which would actually be stuff going the other direction. Things are going from bridged to native. They have too many assets that they take delivery on a bridged USDC chain. They would have to use the 7-day canonical bridge to get those assets off that chain. And so there could be a cost there. We can walk you through, guys, all the kind of financial engineering of this. I think it's pretty manageable and pretty low cost on how this all works in these use cases. But those would be, I think, the downsides to this approach. Although the advantage is the typical user will just see USDC and they won't think native or bridged. It just will kind of be abstracted away.
Cool. Thanks, Hart. Any additional questions on the bridged USDC standard or moving between chains via intents? Okay. So I'm going to move to the next slide then that kind of gets to Hart's question, which was, what about the interoperable bridged USDC standard? So to clarify, what we're bringing to market in August will just be, it won't have interop enabled. We are still seeking feedback on the interoperable bridge USDC standard. So effectively taking that same compliant bridge USDC token, but making it fungible and portable with other chains that have that compliant token using interop. We have some open design questions that Skeletor will guide us through in a second, but some of them being, okay, if the token standard is upgradable, how do we mitigate security risks when chains share a lockbox? Who owns the ability to upgrade? And then one thing that could be pretty interesting is today, when you are locking, issuing the bridged USDC on an L2, you are relying on L1. What if you could bootstrap your liquidity from potentially OP mainnet via a lock-in mechanism? So the design docs there, we are still looking for feedback, as Mauricio alluded to. And what that would enable is effectively optimizing inventory rebalancing, going back to our example here. Okay. So here we have an example similar to what we showed earlier on. user wants to move 5 USDC from L1 to chain A, you can see here that there's 5 USDC in the lockbox, 5 USDC on chain A, and 0 on chain B. Then the user wants to move 4 from chain A, 4 from chain A to chain B. You see the amount in the L1 lockbox does not change, and ultimately there's 1 USDC on chain A and 4 USDC on chain B. Now, the interesting thing about this is if the user wants to exit via chain B, remember we had that under collateralized issue with our ETH example. With interoperable bridged USDC, if we can get this right, we're actually able to ship it with a single lockbox design, meaning we don't have that same issue. So the user would just be able to exit straight back to L1. And I think one key thing we want to talk about here is hypothetically, once we get this design right, how would the upgrade look from the August version to the interoperable version? And Skeletor, do you want to talk about this here?
Yeah, absolutely. So the main difference between this approach and the previous one, kind of the, let's say the non-interop and the interop version of the bridge USDC standard, is that, as Zain said, if every chain operator is the owner, or let's say not even the owner, but is in the control of the upgrade keys to upgrade the bridge USDC into native USDC, then those bridge USDC cannot be fungible between themselves. So the question is, okay, for interop to be a thing and not to have a shit ton of lockboxes on every L2 and every other L2 on the interop set, which is a pain in the ass, we need to figure out a way to make the trust assumption the same for all the chains and for all the chain operators that want to have the bridge USDC. So to do this, basically, we moved some of the role and permission management to a trusted third party. This trusted third party can be, I don't know, whatever. I will not go into details. Maybe Zain, you can go into details afterwards. But what it will do, besides besides setting the circle controlled address for a specific chain, in case that specific chain wants to migrate into native USDC, it also controls the implementation code, or let's say the address to the specific implementation for the different parts of the system. Those parts being the adapters on L1 and L2, and obviously the implementation of the super USDC, which in most cases will just be the vanilla bridge USDC version. But if anything changes in the future, we might want to have some flexibility that there for the trusted third party to also submit changes. So yeah, that's it. I mean, the key part here is that we designed this system with kind of this separation of concerns in mind, in which right now the current shippable version is focused on chain operator control, but the interop version will be focused on this trusted third party control, and the chain operator basically is removed out of the equation. And this is a fully permissionless system. Anyone can deploy a specific bridge USDC to your specific L2. As for the question before, like, okay, why would a chain operator not want to have the bridge USDC version? I mean, you wouldn't even need to choose, right? Like somebody will deploy it if they need to. That being across because they need to fulfill an intent or whoever.
Cool, thanks, Skelly. So this, more than anything, we'd love feedback, especially if you don't have bridged USDC on your chain. Again, there's the design doc linked. If you want to drop any ideas, suggestions, we'd love to hear your feedback. Okay. With that being said, we had a previous session on how to contribute. If you're looking to do so, you can click the YouTube video link here. And then we recently started up a protocol research and development Discord server. So you can see all of the open development happening for Interop across the channels. If you have any questions, feel free to join it and join the discussion there. With that being said, I'll pause the recording, but We do plan to do another one of these sessions on the standard ERC20s as well as native ERC20s. So if you have any feedback on the session, things that you want to see that weren't covered today, please give us a shout. You can just drop a comment in the Superchain Friends Slack group, and we'll iterate accordingly. And then Rishi, how would the bridge work with Circle token contracts as they don't support the OP mintable interface? Is that, Rishi, are you alluding to the bridge USDC standard?
Yep, exactly.
Amazing. Okay. Skeletor, do you want to?
Yeah, I can take that. Yeah, so that's the main reason why we need the adapters. So the adapters are the way, like the best way to wrap the underlying bridging mechanism that for this specific use case is the Optimism cross-chain or cross-domain messenger. And the way we're using it is not as the standard bridge right now, which is, hey, you're locking and you're minting on the other end. We are just using it as a messaging layer bridge. So we are just sending some like bytes of data from one end, and we say, hey, this adapter on L1 is communicating to that adapter on L2 that some USDC has been locked, and the adapter on L2 knows and trusts the adapter on L1. So it says, oh, okay, I trust that some USDC have been locked on my paired adapter on L1, so I will mint the bridge USDC. And bridge USDC has allow list for minters and burners. So in any case, if we would need to, deploy a new adapter because something changed or because whatever reason, we can do that, and we can just add a new minter to that bridge USDC.
Yeah, sure. Thanks.
No worries.
Thank you very much. Any other questions before we wrap up today? Okay. Thanks everyone for joining. I'm going to stop.